Good morning. Let's start our lecture today. So in the last class, we were trying to solve the Euler equation. All right, the Euler equation has the following form. So you have at squared x second plus btx prime plus cx is 0. The characteristic equation is ar squared plus b minus ar plus c is equal to 0. So for this character, so in the previous class, we were trying to solve the Euler equation, right? So this is the form of the Euler equation. The difference between the Euler equation and the other second order differential equation with constant coefficient is the appearance of t squared and t. Then you also have a characteristic equation, which is ar squared plus b minus ar plus c is equal to 0. For this equation, the delta is b minus a squared minus 4ac. All right. So there are three cases. Case number one. So if delta is positive, you have two roots, R1 and R2. They are minus of b minus a plus or minus square root delta over 2a. All right. So in this case, you have two solutions, and the general solution should be C1 t to the R1 plus C2 t to the R2, right? So case number 2, when delta is 0, you have only one double root, right? R is minus b minus a over 2a. And then in this case, you have x is c1 t to the r plus c2 t to the r log t. Yes. Right? This is where we were last term. So let us do some examples on case number 2. Example. So find the solution of um, 90 squared x second so yes, so sorry. This is 7 t squared x second minus 7t x prime plus 16 x is equal to 0, right? So what is the characteristic equation of this equation?
R squared minus 8r plus 16.
Yes, can you sign back the paper, please? So this is r squared minus ar plus 16 is 0. So in this case, you have one double root 4, and the solution will be t to the 4 plus c2 t to the 4 log t. All right? So in the previous class, I gave you a hint of how to find the second solution, given that you know the first solution. What is the method that you can use to find the second solution, t to the 4 log t, when you already know the first solution? Yes?
With the classical characteristic equation, what we did in finding the second solution for a double root was we multiplied by a function that was, I guess you would call it lower in power, because we went from an exponential to a polynomial function, whereas this time we have a polynomial function, so we know that we'll multiply.
Yes, this is trick, but what is the method to find the solution?
Reduction of order.
Yes, can you say it back, please? So now we want to use the reduction. So suppose that we know x1, we will prove that the second solution can you both sign that? We will prove that the second solution should be t to the 4 log t using the reduction of order method. All right. So now, if you find the first solution, which is given by t to the 4, I will have to show that the second solution is of the type t to the 4 times log t, right? And the method that I use will be the reduction of order method. Right, so what is the idea of the reduction of order method? Yes?
That you bring in W, which is x2 over x1, and then, so x2 would be W x1, and then from there you solve for, you plug that into the equation, and then W prime
Yes.
is.
Can you stand it back paper, please? All right, so we suppose that x2 will be W x1, and we will try to find W. All right? Right, so you define W to be x2 over x1, and then you're going to find W. Right. So in this case, x1 is going to be t to the 4, so x2 will be W times t to the 4. And we plug, so since x2 is the solution, you're going to have t squared x2 prime second minus t x2 prime plus 16 x2 is going to be 0. All right? So in this case, you're going to use the reduction of order method to find W. Basically, we're going to show that W is log t. All right? To do that, you write x2 to be W t to the 4, and you plug it into the equation, right? So x2 is another solution, which means that t squared x2 second minus t x2 prime plus 16 x2 is 0, right? Now I replace x2 by W t to the 4 second minus 7t W t to the 4 prime plus 16 W t to the 4, and this is equal to 0. All right, now I have to take the first and the second derivative of this guy. So what is t W t to the 4 prime? I want to take the derivative of this guy, yes?
Well, the first derivative would be
This one?
Yes, it would be W times 4t to the 3.
Yes.
And then it would be plus t to the 4 times the derivative of W.
Yes, can you stand back paper, please? So this gives you W prime t to the 4 plus t to the 4 prime W. So this is product rule, and this is W prime times t to the 4 plus 4 t to the 3 W. Right? It's good. Now I'm gonna have to take the second derivative, which means that I have to take this derivative of both of these guys. So what is it? Yes?
So you would do the derivative of each one again, so it would be W w prime 4t to the third plus 12t to the second
Yes.
w.
Can you stand back from this? So now you're going to apply the chain rule again. So this is w second t to the 4 plus 4 t to the 3 w prime plus 4 t to 3 w prime plus 12 t squared w. This gives me w second t to the 4 plus 8 t to the 3 w prime plus 12 t squared w. All right, explain again. The idea is to try to find an equation for the ratio between x2 and x1. To do that, I write x2 to be wx1. x1 is c to the 4. And now I replace x2 to be wt to the 4 into this equation. And now I have to compute all of the derivative. All right? So wt to the 4 prime, I'm going to apply the product rule. I have w prime to the 4 plus t to the 3w. All right? So now I have to take the second derivative, which means that I have to take the first derivative of this guy and the first derivative of this guy. So the first derivative of this guy is w second t to the 4, which is the derivative from here, and then I have to take the derivative of the second guy, which is 4t to the 3 w prime. This guy, I have to take the derivative on w, and then I have to take the derivative on 4t to the 3, which is this one. Now I combine these two guys into 8t cubed w prime. Right? Now I have to plug everything back into this equation. I have t squared w second t to the 4 plus 8t to the 3 w prime plus 12t squared w minus 7t w prime t4 plus 4t3 w, and then have to add 16wt to the 4. All right, explain again. So after I compute the second derivative of this guy and the first derivative of this guy, I plug everything into the equation, right? So this, I'm gonna replace it by this one, and that gives me this one. All right? And this guy, I'm gonna replace it with the first guy, and that gives me the second guy, right? After I take the second derivative, I replace this second derivative by w prime t4 plus 8t to the 3 w prime plus 12t squared w, and minus 7. So the first derivative, I'm going to replace it by this computation, and I put it here. So basically this is an equation, and as you can see, for this equation, you don't see x1 anymore. This is basically an equation after this. Now I have to simplify this equation. How can I simplify this one? Yes?
You would combine like terms. And
Yes.
then I think after you combine everything, you would end up with w double prime t6 plus w prime t5 equals 0.
Yes. Can you sign the back paper, please? So the first thing that I have to take out is the second derivative, right? So there is only one second derivative in this term. So I write down t squared w second t4. Now I have to take out all of the w prime. So all of the w prime will be this guy and this guy. So I have 8 minus 7. So 8 minus 7 is 1. So I have w prime t to the 5. Right? To be clear, I have 8 minus 7 w prime t5. All right? So I want to simplify this equation. The first thing that I have to simplify is the second derivative. So the second derivative appears only once. So I put it here. So this is t squared, this is 4, which means that here I have t6. Now I look at the first derivative. I have 8t5 minus 7t5. So this is 8 minus 7 w prime t5. And then I have to look at the zero derivative, which is t4 12 minus 28 plus 16 w t4, and this is equal to 0. All right? It's good. So now I have to collect all of the zero derivative, right? So this is 1, this is 2, and this is 3. I collect all of them. I have 12 minus 28 plus 16. So I have 12 minus 28 plus 16 WT4, 0. So this guy is 0, and this guy is 1. Right? And we end up with t to the 6 w prime second plus w prime t to the 5 is equal to 0. All right? So this is the equation. So how can we simplify this? Yes?
We can define a new variable v such that...
Not yet, not yet.
Oh, well, we can factor out t.
Yes, can you stand back to it, please? So now I can, I see on both sides I have t to the 5, so I put t to the 5 to be the common factor. I have t to the 5, t, w second plus w prime is equal to 0, which means that t, w second plus w prime is equal to 0, right? So how can I solve this equation? Yes?
Would you now plug in the v equals w prime? Or do we?
Yes, yes, and back please. So now you define v to be w prime, then you have t v prime plus v is 0. All right? It's good. Right? So basically, this is the reduction of order method. Right? So this is order reduction step. Basically, in this method, this is step where you see that there is an order reduction, right? You go from second order differential equation to first order. This is second order differential equation, and this is first order differential equation. So how can I solve the last equation? Yes.
Well, we can write it out as t times dv dt plus v, then we can separate the variables and integrate both sides.
Can you say it back, please? So basically, this is the first order differential equation, and it is also separable, right? So this is the simplest equation in this class. So you can solve this by using the separation of variables method. Separation of variables. Alright, so now you're going to use the separation of variables method to solve this equation. You have t v prime is equal to minus v, which means that t dv over dt is minus v, which means that dv over v is minus t dt, right? Right? So this is the first order differential equation, and this is separable. So what you can do is the simplest method, which is the separation of variables. You write v prime as dv over dt, so you have t dv over dt is minus v. Now you split, you put v to the left hand side and dt to the right hand side. So I think I have 1 over t. Right? So I have dv over v is minus dt over t. How can I solve this equation? Just can sign back paper, please. So so I'm gonna use I'm gonna integrate both sides, right? So you have dv over v is minus dt over t, which means that log of v is equal to minus log of t, right? Which is log of 1 over t. So v now is 1 over t. So what is w? Right, so it, yes? No? Yes, can you say it back, please? So w will be the antiderivative of v, and this is log t. Right? I explain again. So at this step, you have a first order differential equation, which is the simplest one. And this is also separable. So the simplest method can be applied. So the simplest method in this case is the separation of variable method. All right. So what you do is that you write v prime to be dv over dt. So basically, you have t times dv over dt is minus v. You put dt to you put all of the t to the other side, and you put all of the v to the left hand side. You integrate, you find log v is log of 1 over t, so v is 1 over t, and w is 10 log t, right? So this is how you prove that the solution to the second solution should be the first solution times log t, right? Questions? It's good? It's clear? Right, so now let us go to the third case. So the third case, so the characteristic equation is a square plus b minus ar plus c is 0. The delta now is b minus a squared minus 4 times ac, right? Case number 3. Delta is negative. In this case, you also have two roots, right? As we discussed in the previous class. So the two roots will be minus b minus a plus or minus square root of delta over 2a. All right, in this case, delta is negative. So we discussed in the previous class that we have minus b minus a plus or minus I times the absolute value of delta over 2a. All right? And in this case, the first solution should be t to the r1, which is t to the minus b minus a plus I square root delta over 2a, right? So the first solution should be t to the r1, which is minus b minus a plus I square root delta over 2a. So here I have the real part and the imaginary part. The real part is fine, so I have b minus t to power minus b minus a over 2a. And then for the imaginary part, this is the problem, so you have over 2a. This is the minus. Right? So you're gonna write a solution as t to r1. So t to r1 has two parts, the real and the imaginary part. So the real part is fine. This is minus b minus a over 2a. The problem is now in the imaginary part. So how can we overcome this difficulty? How can I write t to the I or something? Yes?
If we can use Euler's formula, then we
Yes.
get rid of the imaginary. So what we can do is we can write t as e to the line t, because that is t, because e and line t are
Yes.
inverse functions.
Can you sign back paper, please? Right. So so you're gonna write t to be log t. So now you have t is e to the log t, right? T is e to the log t. So now this part, you're gonna write it minus b minus over 2a. T e to the log t times I square root delta over 2a. All right, so this is t minus b minus a over 2a. E to the log t I square root of delta over 2a. Right. So who can tell me what is the form of this under the Euler formula? Yes.
The Euler formula was that e to the alpha I will be cosine alpha plus I sine alpha.
Yes.
So in this case, we'll have cosine ln t squared of delta over 2 plus I sine cosine ln t squared of delta over 2.
Yes. Can you stand back quick, please? So here you have t minus b minus a over 2a cosinus of log t square root of delta over 2a plus I sinus of log t square root of delta over 2a. Right? This is the Euler formula. I recall you that the Euler formula is the following. So e to the I theta will be cosinus of theta plus I sinus of theta. So in this case, we apply the Euler formula for theta to be log t square root of absolute value delta over 2a. All right? The Euler formula said that e to the I theta will be cosinus of theta plus I sinus of theta. In this case, we choose theta to be log t square root delta over 2a, right? So this is a very nice formula because when you choose theta to be pi, what you have is ei pi is cosinus of pi, which is 0, plus I sinus of pi. So this is minus 1, and this is 0. So you have minus 1, which means that ei pi plus 1 is 0. Right, so in this formula you have all of the numbers that we have. So ei pi 1 0. So any questions? It's good. I explain again. Right. So for the second case, for the third case, delta is negative. So in this case you have two roots, minus b minus a plus or minus square root delta over 2a. In this case, delta is negative. So what you do is you have to put an I, and here you put absolute value, right? So the first solution should be like the previous one. You have t r1, and then the r1 will be minus b minus a plus I the square root delta over 2a. The first part is the real part. You can do it normally. The second part is the imaginary part. To take the power of an imaginary function, what you do is you write t as log e to the log t. And so this you arrange it to be e I log t square root of this guy. And now you apply the Euler formula. So the Euler formula is e to the I theta is cosinus of theta plus I sinus of theta. In this case, theta is this guy. Right? Questions? All right, so now let us go to R2. X2. X2 will be t to the R2, and in this case, this is t minus b minus a over 2a minus I square root of delta over 2a. Right, so how can I do this? Yes?
The form will actually come out to be the same once we do the same process, only we'll have a minus sign inside the cosine and inside the sine. But we can use trigonometric identities because a cosine is something of a negative angle is just cosine of that angle, and sine of a negative angle is just negative sine of that angle.
Yes.
So it'll actually come out to our same formula except there'll be a minus sign
Yes.
before the I.
Can you stand back to paper, please? So here you have t to power minus b minus a over 2a, and then you have t to the I minus I square root of delta over 2a, right? Right, so you do exactly like in the previous case. you split the real part and the imaginary part. So the real part is this guy, and the imaginary part is this guy. So for the real part, you don't do anything. It's the standard thing. And for the imaginary part, you have to do the same trick. You have e to the log t, right, times minus I square root delta over 2a. And then you have minus b over a 2a. And then you have minus I log t square root delta over 2a. Right? So you do exactly the same thing. You have the real part and the imaginary part, you split them. The real part will be the same, and the imaginary part you write it like log t. But here you have a minus. The only difference is here you have a plus, and here you have a minus. All right? So here you're gonna apply the Euler formula again. So this is cosinus of minus log t square root of delta over 2a plus I sinus of minus log t square root of delta over 2a. All right? It's good. So you do exactly the same thing, except here you have to add one more minus because here you change plus to minus. All right? So in the final formula, you're going to have minus here and minus here in the sinus and cosinus. Now, but cosinus of some of the minus is the same with the cosinus with a plus. So I have cosinus of log t square root delta over 2a minus I sinus of log t square root delta over 2a. All right? Because here we have what? We have cosinus of x is cosinus of minus x, and minus sinus of x is sinus of minus x. Right? Questions? Right, so for the second case, you do exactly the same thing, and at the end, you have to have the minus in the cosinus and the sinus. But you know that cosinus of minus x is the same with cosinus of x, and sinus of minus x is minus sinus of x. So here you have to replace the plus by a minus. Questions? Right. So now you have the formula for x to the r1 and x to the r2. So x to the r1 should be this guy, and x to the r2 should be this guy. All right. What is the general solution for this? Right, so I have x1 and x2. What is the general solution? Yes?
Is it just a constant times x1 plus constant times x2?
Yes, can you sign it back paper, please? So you're gonna, so the general solution, I'm gonna erase everything and I put a constant. Right, so the general solution will be so x will be c1 x1 plus c2 x2. And which means that you have to put c1 here, and you have to add c2 here, right? So in this case, you have what? You have x is c1 x1 plus c2 x2, which means that I have to put c1 times the first guy plus c2 times the second guy. Can we simplify this expression? So I have C1, T2, this guy, cosinus plus I sinus, and here I have C2, this guy, times cosinus minus I sinus. Can I simplify this expression?
square root of delta over 2a, and then plus c1 minus the c2 times the same.
Can you say back at the back of the paper, please? So right, so you can factor this cosinus, right? So the first thing I have is this one combined with this one. So I'm gonna get c1 plus c2 t to the power minus b minus a over 2 cosinus of log square root of delta over 2a. This is the first guy, right? So I put t to the power minus b minus a over t to the power minus b minus a over 2 times cosinus log t square root delta over 2a as the common factor. And then here I have c1, here I have c2. So I put c1 plus c2. Now the second guy will be c1 minus I c2 times t to power b minus a over 2a times sinus of log t square root of delta over 2a. Yes?
Will the C1 also have an I as well, multiplied by it?
Yes. Can you sign the back of paper, please? So you have an I here, right? So you can simplify this expression by putting t to power minus b minus a over 2a times cosinus as the common factor and t to the power minus b minus a over 2a times sinus as a common factor. So the first one give me c1 plus c2, right? So this is the first things here. The second thing is c1, c2 with an I here, right? Combined with c2 and minus I here. And you have this one, right? For the sinus, you have c1 times I and c2 minus I. So the common factor for cosinus will be c1 plus c2, and the common factor for sinus will be I c1 minus I c2, right? Questions? Right. So now I can forget about this, and I said that okay, this one I put this to be c1 tilde, and I put this to be c2 tilde, right? So this is basically the general solution of our equation. And now, because this is simple, you can define, instead of the other complicated one, you can define this to be x1 and this to be x2, right? So you define the new x1 to be minus b minus a over 2 times cosinus, and the new x2 will be minus b t to power b t to the power minus b minus a over 2a times sinus to be x2, and then the general solution will be the linear combination of the two. Okay, so yes.
Did you take away the I because it's a number? Like, is it part of your C2?
This is C2 tilde, right? So it's a number. I is also a number. So this is x1 plus c2 x2. So I c1 minus c2 is a number, right? And this is part of the c2, right? Questions? Now to compare with the previous case, right? So to compare with the third case in the previous equation, so for the equation when you don't have you have constant coefficient, right? So the characteristic equation will be AR squared plus BR plus C0 when delta is B squared minus 4A, and this when this guy is negative, you also have two roots, right? So the first one will be one is minus B plus minus square root of delta over 2A. And this is basically minus b plus I square root delta over 2a. Right? So the solution will be exponential of minus b over 2a t cosinus of square root of delta over 2a t plus c2 2a t sinus of square root of delta over 2a t. Right? So let us recall the previous case when you have constant coefficient second order differential equation. You have ax second plus bx prime plus cx 0. In this case, the delta is b squared minus 4a. So when this guy is negative, case number 3, right? This is also case number 3. When the delta is negative, you also have two roots, minus b plus or minus delta over 2a, which gives you minus b plus or minus I square root delta over 2a. What you get is e to the power minus b over 2a t and cosinus, and e to power minus b over 2a t sinus, right? So in this case, you see clearly that you go from exponential to polynomial, and here you have a t, here you have a log t, right? So this is how you remember those formulas. You just go down one level, all right? So you go from the third case, this is how you remember it, right? So for the first case of the constant coefficient equation, you see that in the equation you have an exponential of t. You have to go down to the polynomial here. Of course, the constant are different, right? But you have to have you have to keep in mind that the constant are different. And then here you have cosinus of t. So this t will go down to log t. All right? And everything is the same. This is how you remember those formulas. Questions? Is good? All right, so if there's no questions, let us go to another example. Right, so let us try to solve another example. You have 9t squared x second plus 15t x prime plus 5x is 0. Right, so in this case, this is the equation. I want to know what A, B, and C. Yes?
9, 15, and 5.
Yes, can you say the back paper, please? 9, 15, and 5. Characteristic equation. So what is the characteristic equation for this equation? Yes.
It would be 9r squared minus, and then 15 minus 9 is 6, so plus minus 6r plus 5 is equal to 0.
Yes, can you say the back paper, please? This is, so you have 9r squared plus 15 minus 9, so there's no minus. And plus 5 is 0. So you have 9r squared plus 6r plus 5 is 0. What is the delta in this case? Yes?
The delta would be 15 squared minus 4 times 9 times 5.
Yes, inside inside back paper, please. The delta will be 6 squared minus 4 times 9 times 5. Right? So this is 36 minus this is 20, 21. Right? So the delta will be this guy square minus 4 times the first and the third guys. So this is 66 squared minus 4 times 9 times 5. So this is 118. So 118 minus 60 is 4. This is minus 1. Right. Right. So so what are the two roots? Yes.
It would be -6 plus or minus I times the square root of 144 all over
Yes.
all over 18.
Yes, can you say it back to this? So the two roots will be -6 plus or minus square root of I times 144 over 2 times 9. All right. So what is the square root of 144? Yes, can you say it back to this? So here you have -6 plus or minus I times 12 over 18. So this gives me -1/3 plus or minus 2/3. All right. So I explain again. So this is now after you have all the formulas, then this is an easy game. You have A is 9, B is 15, C is 5. So the characteristic equation will be 9r squared. This 15 minus 9, so this is 6, and this is 5. So you have 9r squared plus 6r plus 5. The delta will be 6 squared minus 4 times. So the middle guy square minus 4 times the first and the last guy, which is -144. So the two roots will be -6 plus or minus I square root 144 over 2 times 9. So this -6 plus or minus I 12 over 18. So this is -13 plus or minus I 2 over 3. What are the two solutions? Yes?
The solutions are t to the 1/3 times cosine of, inside the cosine is 2/3 ln t, then plus t to the 1/3 I sine, and inside the sine is -2/3.
Yes. Can you sign back by this? So now to find the two, this is going to be easy. So you have -1, and here you have 2/3, right? This is the I. You don't care about the number here. So this guy will go to e to the power of 1/3. No, sorry. T to the power of -1/3, right? So you just look into the real and the imaginary part. You don't care about the sign. So the first guy will give you t to the power of -1/3, and the second guy gives you cosinus of 2 over 3. And then you have to remember this is log and this is not t. Right? And the second one is sinus. So the general solution will be C1 t to the power -1/3 cosinus of 2 over 3 log t plus C2 t to the power -1/3 sinus of 2 over 3 log t. Right? I explain again. So after you find the two roots, you write this way. So you have -1/3. You don't care about the sign in the middle. You have I times 2 over 3. So the -1/3 will go to the t. So you have t to the power -1/3, t to the power -1/3, and the 2 over 3 will go to the cosinus and sinus, right? And then you just linear combine them and you get a general solution. Questions? That's good. Right, so let us go to, so if there's no questions, let us go to another example. So example, you have t squared x second minus tx prime plus x 0. So in this case, what is A, what is B, and what is C? Yes?
They're all in one, or 1, negative 1, and 1.
Yes, can say back of this. So this is 1 minus 1 and 1. Right? So the characteristic equation. Yes?
Will be r squared minus 2r plus 1.
Yes, can say back papers, please. So this is r squared minus 2r plus 1, 0. So what is the root of this equation? Yes?
It would be 2 plus or minus I times, well, what's it down? Yeah, like I square root of,
No, no, there's no I.
there's no I.
So what is the root of this equation? Yes?
0?
No. So this is not 0, this is not, there's no I. Yes?
Wouldn't it be r equals 1?
Why?
Double root?
Yes. Can you sign the back paper, please? So this is nothing but I minus 1 squared, right? So which means that you have a double root. Right. So for this equation, you can write r squared minus 2r plus 1 as r minus 1 squared. And which means that this equation has a double root. What are the two solutions of this equation? Yes?
The first solution will be t, and then the second one will be t times line t.
Yes, can you and my practice. So the first one, right, will be t to the r, and this is t, and the second one will be x1 times log t, and this is t log t. Right, so the general solution will be c1 t plus c2 t log t. All right? So again, in this case, A is 1, B is minus 1, C is 1, so the characteristic equation will be r squared minus 2r plus 1, which can be written like r minus 1 squared, so you have a double root, 1. The first solution should be t to the r, which is t, and the second one should be t times log t. And that's it. Questions? So let us go to another example that you understand the concept of this equation. So you have t to the 4x for derivative plus 60 to the 3 x3 derivative plus 70 squared x second plus x prime minus x is equal to 0. Right, so this is fourth order equation, but the same method applied. Right, so any ideas how you can solve it? Yes?
Do we want to find a characteristic equation such that it's not dependent on t, like we
Right.
did for the Euler question?
Right.
So if for t squared we use t to the r, and this one is fourth order,
So what should
going
we do?
one down from that is we should look for solutions of a special type.
Right.
And since with a second order derivative, we look for solutions of polynomial form. Going, maybe third derivative would be logarithmic form, and then fourth derivative
It's not
would
that
be
complicated.
Oh.
Any better idea? Yes?
So if we let x equal be the form of t to the power of r, if we take the derivative of x in that form goes 4 times, and then substitute back the original equation, we should cancel out the t boys and we get end up with the characteristic equation.
Yes, you can say back paper, please. So here you still use the same special solution, right? So again, we still use x to be t to the r, right? So in this case, so the thing that you can, you know how you can right. So let me explain. So the degree of x is r, right? In t. So what is the degree of x prime? Now, so I mean, I don't compute, but I know that this is the good one, right? Why? Because I look at the degree. So the degree of x is r, right, in t, because here x is a polynomial of degree r in t, right? So x is a polynomial of degree right? So you know that, okay, if I choose this form, the special solution of this form, which means that x is a polynomial of degree r in t. So what is the degree of x prime? Yes?
R minus 1.
Yes, can you sign back paper, please? It's r minus 1. Right, so what is the degree of x second? If I go down another derivative, yes?
It will be r minus 2.
Yes, can you sign back the paper, please? So this is r minus 2. All right? So what is the degree of x cubed? The third derivative of x. Yes?
R minus 3.
Yes, can you sign back the paper, please? R minus 3. What is the degree of x? Fourth derivative of x. Yes?
R minus 1.
Yes, can you sign back paper, please? All right, so now you have all of the degree. So now I'm gonna watch the degree of t to the 4 x 4. What is it? You know that this guy is a polynomial of degree r minus 4 in t, right? What is the degree of t to the 4? Yes?
Just
This is just b1.
R minus 2.
No. You have a polynomial of degree r minus 4 times a polynomial of degree 4. What is the total degree?
Oh, R.
R, yes. Can you sign back the paper, please? So r minus 4 plus 4, and this is r. Right? So this is the degree of x 4, and this is the degree of t to the 4. Right? So you multiply the two polynomial or different degree, then the total degree will be the sum. Right? So this is so when you have t to the a times t to the b. So this is degree a and this is degree b. Right? So when you multiply them, you have t a plus b. So this is degree A, and this is degree B. So the total degree will be right. So you multiply something of degree A times something of degree B, then you get something of degree A plus B. This is the same. So x4 will be of degree r minus 4, and t4 is the degree 4, so the total degree will be r. Right? So now, what is the degree of t cubed x3? Yes?
R.
Yes, can you say back paper, please? So this is still r. Right? So this is x third derivative, and this is x cubed. So this is still r. So now what is the degree of x t squared x second? Yes?
R.
Yes, r again, right? So this is r minus 2 plus 2, and this is r. Right, so this is x second, and this is t squared. So what is the degree of tx prime?
R again.
Yes, can you say back paper, please? So this is r minus 1 plus 1, and this is r. Alright, so this is x prime, and this is t. And you know that the degree of x is also r. So, what?
In the equation, should it be t times, oh, it is t times x prime. I'm sorry, I didn't see that.
So this is plus t times x prime. Right? So now you observe that in all of the coefficients of that equation, you have degree r. Alright, so which means that t to the 4 x prime plus t cubed x 3 plus t squared x second plus tx prime minus x is of degree. And that means that you can use the math. You can find a characteristic equation because you can pull out T3R outside. All right? So the key idea, if you observe this kind of thing happen, if you replace T3R into this equation, and then all of the degree of all of the terms are the same, then you can use the method of characteristic, and this is how you recognize it. This is the criteria that you see that you can establish a characteristic equation in the first place, right? So let me explain in details why it works. All right, but this is how you know that for a differential equation you can use the method of characteristic with respect to this polynomial, right? So you have to see that all of the degree of all of the terms are the same, right? All right, so now let's compute that. Right, so in this case, x is going to be t to the r. Right, so what is tx prime? Yes?
R t to the r.
Yes, can you say it back paper, please? So x prime will be t to the r minus 1. So tx prime will be t to the r. So what is x second? Yes?
Will it just be r minus, it'll just be r times r minus 1 times t to the
R minus 2.
T to the
Can you say it back paper, please? So x second will be r minus 1 t to the r minus 2, and so what is t x squared x second? This 70 squared x second. Yes?
That would be 7 r times r minus 1 times t.
paper, please. So it's going to be 7r minus 1 t to r. So you are happy because everywhere you have the t to the r. And because of the t to the r, you can put that as a complement factor at the end, and you remove it, right? So I explain again. I choose x with t to the r. So x prime will be r tr minus 1, and this is tx prime will be r t to the r. So here you keep t to the r, right? So for x second, it's going to be r minus 1 tr minus 2. So here, when you multiply that with t squared, you still get t to the r. You are happy because at the end, when everyone has t to the r, you can put that as a common factor and you get rid of the t. Right, so what is x? Third derivative of x. Yes?
It will be r times r minus 1 times r minus 2.
Yes.
T r minus
Yes, can you sign the back of this? So this is going to be r minus 1, r minus 2, t to r minus 3. Alright, so this gives me 60 to the... So what is 60 to the 3 times the third derivative of x? Yes?
Will it just be 6 times r minus 1 times r minus 2 times t to the r?
Yes, can you sign the back of this? So this is 6, r minus 1, r minus 2, t to the r. Alright? So again, you see t to the r, and you're happy because at the end, you're going to remove all of the t to the r. So you're going to have to take the fourth derivative. What is the fourth derivative in this case? Yes?
It will be r times r minus 1 times r minus 2 times r minus 3 times t to the r minus 5.
4.
Minus 4.
Can you stand back paper, please? So you have r minus 1, r minus 2, r minus 3, t to r minus 4. So this gives me t to the 4x fourth derivative. This is, what is it? Yes?
the r times r minus 1, r minus 2 times r minus 3, all times t.
Yes.
R.
Can you stand back paper, please? So you have r minus 1, r minus 2, r minus 3, t to the r. Again, this is t to the r, and you are happy. Now you have to put everything together. Right, so t to the 4x 4 plus 60 squared x cubed plus 7t squared x second plus tx prime minus x is going to be, this is 0. And you have what? You have r minus 1, r minus 2, r minus 3. Plus 6r minus 1, r minus 2, plus 7r minus 1, plus r minus 1. So this is t to the r, t to the r, t to the r, t to the r, and here you have t to the r. Right? So after you put x to the r is x to be t to the r into the equation, this is what you get. All right? So what is the next step? Yes?
Factor t to the r out.
Yes.
each of them, and then
Yes.
you can remove that and expand each of the separate ones, combine them terms.
Yes, can you send back paper, please? So now you have t to the r everywhere, so you can put that as the common factor. Right, so this is t to the r, minus 1, minus 2, minus 3, plus 6 times r minus 1, minus 2, plus 7 r minus 1, plus r minus 1. right? Because I have t to the r everywhere, I can put that as a common factor, and this is equal to 0, which means that I can eliminate the t to the r. So I have r minus 1, r minus 2, r minus 3, plus 6r, r minus 1, r minus 2, plus r minus 1, and this is 0. All right, so this is the yes? This is the characteristic equation. This is the characteristic equation. Since it is independent of t. Independent of t. All right? Yes?
Would you want to simplify it further by taking out the r minus 1?
Yes. Can you say the back of this? This is how you solve it, right? So I explain again. So you want to choose the special solution of the type x is t3r. When you do that, because of the degree criterion that I mentioned, you can get a characteristic equation, and this is the process. You plug t3r into the equation. T4 times x4 is r minus 1, r minus 2, r minus 3 times t to the r. This is t to the r, and you are happy. Now 6t squared x 3 will be 6r minus 1 r minus 2 times t to the r. This is also the t to the r, and you are happy. So you compute everything. And the good thing is that you have the t to the r outside, and you can put that as a common factor. So you can remove t to the r. When you remove t to the r, you get a characteristic equation, because this is independent of t, right? So your job is now to solve this equation. So the good thing is that here you have r minus 1, r minus 1, r minus 1, and r minus 1 Elizabeth said. So this is what you do, right? So you put r minus 1. So now you have to solve the characteristic equation. So put r minus 1 to be the common factor. So so you put r minus 1 to be common factor, and you get r minus 1 times r minus 2, r minus 3, plus 6 r minus 2, plus 7r plus 1 is equal to 0. All right? Right? Questions? I explain again. So after you put the special solution into the equation, the special solution is of polynomial type, so x should be t to the r. When you put it into the equation, the good thing is that you can get rid of this t to the r, and you get an equation which is independent of t. Now, your job is to solve this equation, all right? To solve this equation, what you do is that here you see that here you have a r minus 1 as a common factor, so you can put it as the common factor. So when you put r minus 1, you have r minus 2, r minus 3, 6 times r minus 2, 7 times r, plus r minus 1, plus 1, right? So one solution should be r minus 1, right? One solution is r minus 1, 0, which means that r has to be 1, right? Right? Questions? So this is also one of the questions that I put into the this is also one of the questions that I put into the final exam. So I put the final exam online, and you have until December 16 at 5 p.m. To send me the solution, all right? So, and the solution has to be typed, and I will, so if you don't type it, I will not accept it, right? I will not grade it, and I will not accept late the project either. Okay? Questions? And this is the last questions. This is how you solve the last questions. All right? So far, so good. Now, so which means that the first solution is. So what is the first solution for this equation? Yes? T. Can you say in the back paper, please? The first solution should be t to the r, and this is t to the 1, and this is t. Right? But we have to find another 3 solutions because this is a fourth order polynomial equation. Right? So we now consider r minus 2, r minus 3, plus 6, r minus 2, plus 7, r plus 1. All right? So I have to solve this equation. So here I don't see any special solution, right? So what I have to do is I have to expand it into a polynomial of degree 3. So this gives me, so I'm gonna expand it. Expand the polynomial. So r minus 2, r minus 3 will be. So how can I expand this one? Yes.
You would do r times r squared minus 5r plus 6, and that
Yes.
would be r cubed minus 5r squared plus 6r.
Yes, can you stand the back paper, please? So this is going to be r squared minus 5r plus 6, right? Because r minus 2 times r minus 3 will give you r squared minus 5r plus 6. And this gives you r cubed minus 5r squared plus 6r. All right? So what is 6r? R minus 2. Yes?
6r squared minus 12r.
Yes, can you stand back paper, please? So this gives me 6r squared minus 12r. All right? Right, so now you put everything back into the equation. You're going to get r cubed minus 6r squared plus 6r plus 6r squared minus 12r plus 7r plus 1. All right? So this, I simplify everything. I have r cubed plus r squared minus 6r plus r plus 1 is equal to 0. Right? No, not yet 0. So after I expand it, I plug it back, I get r cubed minus r squared plus r plus 1. This is one of the solutions, right? So we're gonna continue on next Tuesday. Happy Thanksgiving.